The morning of September 7th, 2025, felt heavy with doubt. Starship 10 stood on its launch mount at Starbase, Texas, gleaming under the coastal sun. But behind the scenes, chaos was the order of the day. A tiny, persistent helium leak in the super-heavy booster's plumbing had sent engineers scrambling. For hours, teams worked against the clock, trying to isolate the problem. This was not the smooth countdown SpaceX had hoped for. It was a stark reminder of the immense difficulty of spaceflight. Each delay felt like a step backward, a victory for the laws of physics that constantly conspire against such ambitious machines. This single leak was just the latest in a string of setbacks. The week leading up to the launch had been a trial by fire. A planned static fire test of the booster's 33 Raptor engines was aborted twice due to sensor glitches. Then, a powerful Gulf storm rolled in, forcing a 48-hour delay that tested everyone's patience. The team felt the pressure mounting. Each previous flight had pushed the boundaries, but Flight 10 was different. It carried the weight of expectation. It was supposed to be the flight that proved Starship was not just a prototype, but a truly reusable and reliable launch system ready for real missions. The mood in mission control was tense. Faces were etched with concentration, illuminated by the glow of data-filled screens. For every problem solved, another seemed to appear. After fixing the helium leak, a ground support valve refused to close, threatening another scrub. It was a high-stakes game of whack-a-mole, played with millions of dollars and the dreams of an interplanetary future on the line. These were not the glorious moments seen on the public live stream. This was the gritty, unseen reality of rocketry. It was a battle of human ingenuity against a mountain of complex, interconnected systems. Finally, with less than an hour left in the launch window, a breakthrough came. Engineers managed to cycle the stubborn valve remotely, and the board of indicators turned green. A collective, quiet sigh of relief swept through the control room. The countdown clock resumed its inexorable march toward zero. The initial chaos had been overcome, but the biggest challenges were still ahead. The rocket was ready, but the question remained: would it fly? The entire world was watching, waiting to see if Starship 10 would succumb to its troubled start or rise from the chaos to make history. The success of Starship 10 was not born in the final moments of the countdown. It was forged in the months of relentless work that followed Flight 9's partial success. Engineers at Starbase had become masters of iteration. They treated every failure not as a defeat, but as a data point, a lesson written in fire and steel. After the previous flight, they dissected every piece of a recovered booster engine, analyzing the stress fractures and melted components. They spent countless hours in workshops and labs, redesigning parts to be stronger and more resilient, determined to conquer the weaknesses they had found. Their process was a testament to SpaceX's philosophy: build, fly, fail, fix, repeat. Instead of spending years on simulations, they embraced real-world testing. The team developed new welding techniques to strengthen the ship's massive stainless steel rings. They completely overhauled the filtration systems for the liquid oxygen and methane propellants, eliminating the contaminants that had plagued earlier engine tests. This wasn't just about fixing one problem. It was about systematically hunting down every potential point of failure and engineering a more robust solution, piece by painstaking piece. It was a slow, grueling, but essential process. One of the biggest innovations was the upgraded heat shield. The re-entry for Flight 9 had seen more tiles lost than anticipated. So the engineers developed a new bonding agent and a slightly different hexagonal tile shape. This new design was meant to create a stronger, more flexible thermal protection system. They tested these new tiles in plasma wind tunnels, simulating the hellish heat of atmospheric re-entry over and over again. The goal was to ensure Starship could survive its fiery return to Earth, not just once, but hundreds of times. This was the key to making a fully reusable system a reality. This tireless dedication is what brought Starship 10 to the launch pad. It was the culmination of thousands of hours of effort from a team that refused to accept limits. Every engineer, technician, and welder had poured their expertise into this single machine. They knew that the future of the company, and perhaps humanity's future in space, rested on their ability to learn from the past and build a better future. As the final launch preparations began, the team wasn't just hoping for success. They had engineered it, one problem at a time, turning past failures into the foundation for a triumphant flight. When the countdown finally reached 0, the world held its breath. A torrent of fire and steam erupted from the base of the Super Heavy booster. All 33 Raptor engines ignited in a thunderous roar that shook the Texas coastline. For a few heart-stopping seconds, the massive rocket stood engulfed in its own power. Then, slowly and majestically, it began to rise. Starship 10 was flying. The ascent was flawless. Each milestone was called out in the control room with a steady, professional calm that masked the incredible excitement. The rocket climbed higher and higher, a brilliant spear of light against the blue sky. The first critical test came just minutes into the flight, hot staging. The upper stage Starship ignited its engines while still attached to the booster, pushing itself away with controlled violence. The maneuver worked perfectly. The Super Heavy booster, its job done, began its long fall back to Earth. It executed a series of complex burns, guiding itself toward a virtual catch zone in the Gulf of Mexico. It slowed itself down, deployed its grid fins, and settled gently onto the ocean's surface, upright and intact. It was a stunning demonstration of a controlled landing, proving that the world's largest rocket booster could be successfully recovered. Meanwhile, the Starship upper stage continued its journey. It reached its target altitude and shut down its engines, entering a coast phase. Here, it performed another key test, opening its payload bay door. The PEZ dispenser mechanism, designed to one day deploy Starlink satellites, opened and closed smoothly in the vacuum of space. While there was no payload on this flight, the test was a success. The team then intentionally damaged a section of the ship's flap, using a small onboard tool to test its resilience. This was a bold move, designed to gather data on how the ship would handle damage during a real mission. The final and most dramatic test was re-entry. Starship turned its broad, tile-covered belly toward the atmosphere and began its fiery descent. Plasma licked at the heat shield, turning the ship into a man-made meteor streaking across the sky. On board, cameras showed the tiles glowing bright orange, then cherry red, holding strong against the immense heat. Even the intentionally damaged flap held together. The ship used its flaps to steer itself, performing its famous belly flop maneuver before reigniting its engines for a soft splashdown in the Indian Ocean. Every single objective had been achieved. It was a complete triumph. The successful splashdown of Starship 10 marked more than just the end of a single mission. It was a turning point for human space exploration. For years, the dream of sending people to Mars or building a base on the Moon has been just that, a dream limited by the immense cost of traditional, expendable rockets. With this flight, SpaceX proved that a fully and rapidly reusable super heavy-lift rocket was not a fantasy. The controlled landing of the booster and the successful re-entry of the ship demonstrated a path towards a system that could launch, land, and launch again, dramatically lowering the cost of access to space. This flight was a profound moment for everyone who has ever looked up at the stars and dreamed of going there. It showed that the seemingly impossible was within reach. The intentional damage test was particularly significant. It proved that Starship was not a fragile, delicate machine. It was a tough, adaptable vehicle capable of surviving the harsh realities of space travel. This kind of resilience is absolutely essential for long-duration missions to Mars, where there is no repair crew waiting to fix any problems. Starship 10 showed the world it was being built to be a workhorse, not a show pony. The data gathered from this single flight will accelerate the program for years to come. Every sensor reading, every frame of video from the re-entry, and every stress measurement from the damaged flap will be used to make the next Starship even better. This is how progress is made. Not in one giant leap, but in a series of ambitious, iterative steps. Starship 10's success transforms the conversations about Mars from if to when. It makes the prospect of lunar bases and interplanetary settlement feel tangible, something that could happen within our lifetimes. Ultimately, Starship Flight 10 was a victory for a bold vision of the future. It was a testament to the idea that with enough persistence, humanity can solve even the most difficult challenges. This flight brings us all one giant step closer to a future where humanity is a multi-planetary species. A future where our destiny is not confined to one small blue world, but is spread out among the stars. The journey will still be long and difficult, but after the triumph of Starship 10, the path forward has never been clearer. A new dawn for space exploration is here.